Good day, my name is Misha. I'm one of the Seath framework developers from MLabs, and today I want to show you the demo that we prepared for milestone 3 of our Catalyst proposal. All materials for the demo and source code can be found in Seath repo on the development branch, and by the time demo will be published, everything will be also available in main branch. As a quick recap, Seath is a framework that aims to help the app developers to mitigate UTXO contention problem. There is introduction that we made for milestone 2 demo, and recording is also available. But I will also explain shortly what is the protocol that we're using for demo and the UTXO issue as well here. To keep this demo under the reasonable amount of time, I won't dive too deep into the technical details about how to like start nodes in details and how to integrate your protocol into Seath, but everything will be described in greater details in this document, including like step-by-step instruction how to run nodes from the repo, how to start proper environment, and all details how things works internally and what need to be done to integrate your own protocol into the Seath framework. Let me explain in short the protocol that will be used for the demo. Our protocol is very simple. It's a stateful protocol where state is represented by a single UTXO, its script address, and that UTXO has a datum that holds single number inside. During execution of the protocol, users want to increment that number by arbitrary amount. So let's say we have 4 users and each user want to increment this number by applying this operation. If we do it straightforward way, all 4 users need to build transaction that will perform this increment action, and for that each user will grab this state UTXO, build his own transaction by updating the datum and consuming previous UTXO and producing new one, and then submit transaction to the blockchain. But if all 4 users submit transaction at the same time, only one transaction will succeed because it will consume this UTXO and produce new updated UTXO as transaction output. And for the rest of the users, this UTXO won't be available anymore and their transaction will fail. So they will have to retry, submit transaction, and hope that this time their transaction will be submitted and acknowledged first. In the case of Seath, users do not build transactions directly. Instead, they express their intent or action they want to perform on the protocol using some data type, let's say add, and the number that they want to increment. And then they submit these actions to the leader over the network. And only leader have access to state UTXO. So leader accumulates these actions, then grab UTXO with the state from script address, and then leader builds chain of transaction in such a way that inputs of next transaction in chain depends on outputs of previous transaction in chain. So changes to the state are propagated from one transaction to another, and despite of all transactions are submitted to the chain at once, we will get correct order of the status changes that users wanted to perform on state UTXO, and as a result, all state changes that all four users performed uh, will be in the result of new state UTXO at the blockchain. So this way users don't need to wait while transaction of another user will be submitted, and if they send their actions simultaneously, there won't be any contention because leader will chain transactions properly and submit them on chain. And so this is how SET helps to mitigate this UTXO contention problem. That's it for introduction part, and next I will show how demo is structured, in not going too deep into the details, and how to start a leader node that will be able to accept user requests, and how to run user scenario where users send actions simultaneously to the leader. And we will also see how SET deals with some situation where a chain of transaction is broken and chain need to be rebuilt and resubmitted to the blockchain. Now let me quickly go through structure of the repository and explain what exactly will be executed to showcase Seath capabilities. Demo repository split it into two main parts: off-chain and on-chain. And on-chain part contains validator script for addition protocol, and script is written in Bluetooth, and there is special command available to compile the script, serialize it, and integrate into the off-chain part. I have everything already prepared, so I'm not going to show it now, but again, I will provide instructions into this demo document. The off-chain part is where logic of Seath actually lives, and under the hood it uses Cardano transaction library to communicate with blockchain and build and submit transactions. So main focus of the demo is off-chain part. Here is source code of Seath itself. It contains of three main parts. The core part, which is the heart of the Seath that interprets users' actions and know how to build chain of transactions from them. This is what we showed in our previous demo. Then the network part. Network part contains the logic which required to run a network between Seath nodes. In particular, it contains logic to run user and the leader, and we also call this logic nodes because it's some continuous process of running leader and user logic. So I just will call them user node and leader node, and I will explain how they relate to Seath node in a moment. And HTTP is IP version 4 networking layer that enables communication over the network between separate Seath nodes. So to disambiguate a bit relation between Seath node, user node, and leader node, Seath node is a fully functional unit that will be used by the app developers. And this node can act both as the user and as the leader, because in future there is a possibility that leader will be changed dynamically. And to be able to act as full node, Seath node need to act as a user, as a leader, and perform network communication. So when we start Seath node under the hood, we starting leader node, single leader node, then single user node that will use same signing and validating keys, and web server that will allow network communication between different nodes. So like Seath node is combination of three things. And the full Seath node is actually like described in the demo model that we're going to run. And talking about demo models, they are located in test examples addition demo. The main logic that people who want to use Seath framework will need to implement is located in actions model, and I'm not going to go into details here, but I will explain everything that this model contains in documentation. Basically, it has parts that are required by Seath core to build transaction from user action. And I will explain each function from here into the documentation. And going back to starting Seath node, we need to provide some configuration that is closely related to the part of Seath in source code. So as I told before, to launch Seath node, we need to start leader node, user node, and web server. And here we can see configuration that's required for full Seath node. Here we obtain core configuration that will be required to interpret actions for our addition protocol and build transactions that can perform step on this addition protocol. Then here is configuration for leader node and user node, and again I will explain each of these parts in more detail in documentation. And finally, this part is configuration for web server. So when all these config bits are passed to start function, we will get a constantly running Seath node that can accept a user request through REST API or issue user requests again through IP version 4 network. So this model will be used to launch a Seath node that's gonna act as a leader in this case. It will wait for incoming requests from the users and then build chain of transactions and submit to the blockchain. And second model of the demo is Seath users. It's a bit different in the way that just for sake of simplicity, I'm not going to launch full node there, just one internal user node, because full node generates a lot of logs, especially from the leader side, and user nodes during the demo won't perform any leader job, so we will just have bunch of logs like useless empty logs from the leader. And this scenario runs several users simultaneously. So all output will go to the single terminal, and if we're gonna run like full node, this output will become unreadable pretty fast. But this way we will be able to like trace action of each user, and in another terminal we will see how leader works. At first I plan to like launch a full node for each user in separate terminal, but in this case it's hard to showcase some scenarios like with failing chain when user refuses to sign transaction and stuff like that. So it's still like fully functional user nodes. They just don't do leader job because we don't need it in this particular case for the demo. So with that said, we can move forward and show how things actually run live on pre-production testnet.